Okay, so in part 2 of Unit 4, we're really going to look at writing equations when given some information. So like for instance, maybe I give you just a slope and a y-intercept. You can put that in slope-intercept form. That's what we're going to look at today. Maybe if I give you 2 points, can you write an equation from that? And so on. So for today, we're going to look at writing equations in specifically point-slope form as well as slope-intercept form. And so at the top, we're looking at a review. So it says, what is y equals mx plus b? And so hopefully you're like, well, I remember that is slope-intercept form. So slope-intercept form, where the m is your slope, right? And b is your y-intercept. And then number 2, this is just good review. We want to solve the equation for when we are given x. So we're going to take that value for x and we're going to plug it in over here. So I would write y equals 3 times 14 and minus 1. All right, so 3 times 14 is 42. And then minus 1, we get 41. So we have some new vocabulary in this video, which is point-slope form. And point-slope form is a linear equation. It is a linear, I kind of said that weird, linear equation. And it specifically gives you a point. So gives point and slope, which is where it gets its name, point-slope form. And here's the formula. So that formula is y minus y1 is equal to m times x minus x1. And so embedded in that is the given point and the slope. So the first thing we're going to look at is just writing the equation of a line when given the slope and a y-intercept. So in example number 1, it says, we'll write the equation in slope-intercept form with a slope of 1/4 and a y-intercept of -1. And because they give me slope and y-intercept, my mind is thinking, well, slope-intercept form. And they tell me the slope is 1/4, so that's where I'm going to put it, is right in for slope, and my y-intercept is -1, and so that's going to go in for b. So my equation, so my equation is y equals 1/4 x minus 1. And then I can go ahead and graph that. So I start at -1, and I go up 1 and over 4. Up 1 over 1, 2, 3, 4. Or if I need to go in the opposite direction, I can go down 1 and to the left 4. And make a straight line as straight as possible, and my 2 arrows. So take a minute, pause the video, and try the next one on your own. So it says write an equation in slope-intercept form of a line with the given slope of -2 and a y-intercept of 7. So your equation would be y equals -2x plus 7, where you would start at 7 on your y-intercept, and now my slope is -2, right? I could write that as a fraction of -2 over 1, so that means go down 2 and over 1. All right, as many points, at least 4, I'd say, if you could fit them. All right, so let's move to the next page. So now we're going to take a graph and we're going to go in the opposite direction. We're going to now write the equation. So before they gave you the information, and now I got to pull that information out. So all I need to write an equation, all I need is slope, which we know how to calculate, and the y-intercept, right? And then we can put it in slope-intercept form. So in example A, why don't I zoom up on this? So I see my y-intercept. That's usually the first thing I notice, right? So my y-intercept is at -3. And now I'm going to go ahead and calculate the slope by finding another perfect point. Slope is always rise over run. So I would go up 1, 2, 3, 4. And then I go over 2. And that reduces to 2. So my slope is 2. And you were probably thinking, well, couldn't we have just chosen that point? Yes, totally. I honestly didn't see that until just now. So your equation then is y equals 2x minus 3. All right, so example B, we're going to start with the same concept. I'm going to find my y-intercept. See, that's right here. So my y-intercept looks to be 2. And now I'm going to calculate the slope so I can see that there's another good point right there. And honestly, right off the bat, I can see my slope's negative. So I'm going to put a negative symbol. And it looks like we're going down 1 and over 1, 2. So that means my slope is negative 1/2. So that gives me an equation of y equals negative 1/2 x plus 2. And then C and D I particularly like because those are kind of unique, right? Those are vertical and horizontal lines. So always keep in mind that Vux and Hoy. So C, I see that it's horizontal. So I'm going to think Hoy, right? Horizontal, 0 slope. So M is 0, which I don't necessarily need, but I'm going to put that on there anyways. And my y-intercept is 1. Well, if I know it's Hoy, I just know it's a y equals equation. So it's y equals, and then the number it's passing through, which is 1. And then for D, I would think Vux, because it's vertical with an undefined slope. And then it's just an x equals equation. And so it's going to be x equals, and the number it's passing through, which is negative 4. And that's it. So I think the next point, the next part of the video I think is particularly the most challenging. And that's calculating an equation or making an equation when only given 2 points. So we've got 3 major steps here, and I just realized we have a typo. Sorry about that, guys. So step 1, and then this should actually just say step 2. Jeez. And then step 3. I don't know how I managed to mess that up. So let's change that. Step 2. Step 3. All right, so in number 1, we're going to find the slope. So this is just like how we would find the slope in the last, or that first half of this unit. So we would do negative 8 minus negative 4 all over negative 2 minus negative 3. So again, I know minus and negative turns to plus, so I'm just going to put these plus signs in here. And I would get, let's see, so negative 8 plus 4 is negative 4, and negative 2 plus 3 is 1. Okay, so I can see my slope is then negative 4. So now I have enough information to put this in point slope form. And again, point slope form, because it's on the other page, is y minus y1 is equal to m and then x minus x1. So I'm just going to pick a point to work with. They give me 2 points. And I will, as a rule of thumb, I will just always pick the first one just for consistency, but it really doesn't matter. And just to show you, I'm going to zoom up on this. This is my x1 and this is my y1. So this negative 4 is going to go in here for that y1 here. And then the negative 3 is going to go in for the x1 here. And we already calculated the slope, right? We said our slope is negative 4. So negative 4 is going to go in for that m. So my equation then in point slope form is going to be y minus negative 4 is equal to, okay, then the negative 4 slope times x minus negative 3. Now, I can simplify that a lot because I have a lot of negative minus and negatives. I know this turns to plus and this turns to plus. So let's go ahead and rewrite that. So that's going to give me then y plus 4 is equal to then negative 4 times x plus 3. Now, I don't typically write it like this. I always want to write it in slope-intercept form. So that means I want to get y by itself. So I've got y plus 4 is equal to negative 4 times x plus 3. So from here, I'm going to slowly start to get y by itself, right? So I'll distribute my negative 4, and that gives me negative 4x minus 12, and bring down the y plus 4, and finally, I'll go ahead and subtract 4 to both sides. And now I've written this equation not only in point slope form, but also in slope-intercept. So at this time, maybe you want some more examples. Oh, that's so crazy. I didn't think that would carry with. If you feel that you need more examples, feel free to copy this down. Otherwise, you can fast forward the video. So in the first example, I've got 2 points. I'm wondering how I can just get this out of the way. I don't even know how to delete it. So I have to find those two things. I need to find first my slope, and then I'll put it into point slope form. So I'm going to use 12 minus 8 all over 5 minus 3. So I'm finding my slope. So this gives me 4 over 2, or a slope of 2. So m equals 2. Now I can go ahead and put this in point slope form. So I just always pick my first point, and I'll do y minus 8 is equal to 2 times x minus 3. So there it is in point slope form. So now I'm going to try and change it to slope intercept. Getting y by itself, I distribute the 2. So I get 2x minus 6, bring down the y minus 8, add 8 to both sides, and my final answer in slope intercept form would be y is equal to 2x plus 2. All right, let's look at another example. So this one's interesting because I've got two sets of ordered pair that are negative, so I have to make sure I'm careful here. So I'll do negative 10 minus negative 7 all over negative 4 minus negative 3. A lot of negatives here. So I know that those minus and negatives turn to plus. And so I get, let's see, negative 10 really plus 7, so there's negative 3. And then negative 4 plus 3, okay, so that's negative 1. All right, so a negative over a negative is going to reduce to a positive, in this case 3. So now I'm going to put it in point slope form, and I always use the first point. Now I have negatives here. So I know the formula calls for y minus, but because it's a negative 3, it changes it to plus. It is equal to, and then the slope 3 times, and oopsie, hold on, I just realized I made a mistake. Hold the phone. That's not 3. That should have been 7. I apologize. Okay, so back at it. So I got my slope of 3 times x. Now this is plus 3. So now I can go ahead and get this in slope intercept form by distributing the 3. So I've got 3x plus 9 over here. Bring down the y plus 7. Then I'll subtract 7 to both sides. And I get y is equal to 3x plus 2. All right, and then the final example if you need it. So again, starting with slope, I'll do 15 minus 9 all over negative 3 minus 0. 15 minus 9 is 6. Negative 3 minus 0 is negative 3. So I kind of like this one because now I have a negative 2 as a slope. I'll use this as my point in my point slope form. So I'll do y minus 9 is equal to negative 2 times x minus 0. I'll distribute the 2, and really the 0 just kind of goes away, so I just got negative 2 over there, or negative 2x, I should say. Then I'll add 9 to both sides, and I get y is equal to negative 2x plus 9. All right, now the following page is we're going to essentially do the same thing, except for we're looking at points on a table, and we're looking at it in a real-world situation. So it says a local recreation center offers a yearly membership and charges an additional fee for aerobics classes as shown. Carly's interested in buying a membership, so we want to find, how much is it going to cost her. So we're going to write a linear equation for this. So basically what they did is they've actually given you more information than we need. So each set, like this is an ordered pair. So that would be the point 1, 270. And this is the point 5, 290. So rather than just writing it like how we saw it in the last page, they're just putting it in a table. And it's got bigger numbers. So we're going to start by finding the slope. So we'll do 290 minus 270 all over 5 minus 1. So that gives me 20 over 4, which gives me a slope of 5. Part B says, okay, let's write an equation that represents the total cost of the membership. So they don't specify what type of equation, so I can just put that in point slope form if I want to, but I think it's easier to work with slope intercept, so we'll probably convert that. So we'll do y minus 270 is equal to 5 times x minus 1. And I can go ahead and distribute the 5, and I didn't really leave myself a whole lot of room, did I? And that equals 5x minus 5. And then I'll add the 270 over, so forgive me, I'm kind of running into part C, but I get the equation y is equal to 5x plus 265. And then for C, it says, well, okay, Carly spent $500, so how many classes did she take?
So if we know a total, that's actually going to be my y value because x's represent how many classes, and that's what I'm trying to figure out. So I'm trying to solve for x. So my equation would then be 500 is equal to 5x plus 265. And then I'll start by subtracting 265 to both sides. And you know what? I need to grab my calculator. So let's see. So 500 minus 265 gives me 235. Kind of running out of space here. Seems to be the theme. So 235 is equal to 5x. And then I'll divide by 5. And that gives me 47. So I'm going to do that in a different color just because, not a lot of room. Divide by 5. Okay, so x is equal to 47 classes. So if you felt like that made sense, no need to do some extra practice, but if you would like some extra examples, feel free to keep playing the video and taking good notes. So in the next example, we got a local arcade. It has a crane game that allows you to purchase plays by the minute. All right, so the first thing we're going to do is we're just going to find the slope. You can use any 2 points that you want. I just typically use the first two. So maybe you want to rewrite that. That's 5 and 40 and 10 and 60. So we'll do 60 minus 40 all over, and then 10 minus 5. So that gives me a slope, let's see, that would be 20 over 5, or that's just a slope of 4. So I'm going to put m is equal to 4. So now we're going to write the equation that would represent the total cost. Total cost would be the y value over x minutes. So let's put this in point slope form since I know my slope and plenty of points. I'm going to use this point. It doesn't matter which one you use. You'll end up getting the same answer in slope-intercept form. So I'll do y minus 40 is equal to the slope of 4 times x minus 5. So there it is nicely in point slope form. Now I'm going to get this into slope-intercept by distributing the 4. That gives me 4x minus 20. And the y minus 40 is still over here. And then I'll add the 40 to the other side. And so my final answer in slope-intercept form is going to be y equals 4x, and that turns out to be plus 20. So if I end up spending $500, kind of just like the last example, how long did I play the crane game for? So I'll take that 5, and it's going to be plugged in for y, because y stands for total cost. And then x is minutes, and we don't know how many minutes we spent. So we've got 500 is equal to 4x plus 20. So I subtract 20 to both sides. That gives me 480 is equal to 4x. And finally, divide by 4, and x is equal to 120 minutes. That's a long time. That's 2 hours. That's a lot of time on a crane game. All right, and then the last example here. It says a 5th grade science class is measuring the height of a flower. They just planted over the span of 9 days, assuming it's growing at a consistent height. That usually doesn't happen, but, for the sake of a word problem, I'm going to use the first 2 points here to find my slope. But again, you could use any 2 points. So let's see. I've got the point 1, 0, and then the point 3, 4. And so my slope would be 4 minus 0 all over 3 minus 1. So it's 4 over 2, or that gives me a slope of 2. Now I'll write an equation. So I'll use, this would be really easy, the first point. So I'll do y minus 0 is equal to 2 times x minus 1. And then I'll go ahead and distribute the 2. You know what? I don't like green. It's kind of hard to see. So that gives me 2x minus 2. And really, y minus 0? Okay, so that's just y. And so here's my equation that represents the situation. So if the flower keeps growing at this rate, what's the height? What will the height be after 20 days? So the height is y. That's the outcome. And the time will be x. So what I'll do is I'll plug in 20 for x and solve for y. So that gives me 40 minus 2. Okay, so my height will be 38, and it looks like millimeters.